Wait, I'm pretty sure I've seen those three little dots there before. Well, it's not like any scientists have suggested there are extremely luminous dark stars, not our JWST data. Well, you all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyperrulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Yes. So apparently around the interwebs, we've been hearing things about dark stars. I'm like, whoa, you mean like a black hole? It's kind of like the core of a star that's undergone gravitational collapse so that not even light itself, pardon, can escape its gravitational field. That's not what we're talking about. We're talking about something that was conjectured, I believe, back in 2010. Basically, there was a paper written about dark stars. Basically, in the early universe as we know it, you'd have a whole bunch of hydrogen and helium coming around, and it's kind of come together. But rather than just being a normal star, there'll be some dark matter mixed in there. We're going to go over that because it's very... Basically, they're saying that if dark matter or neutralinos, I believe they call it, links are in the doobly-doo, are their own antiparticle. Basically, if they're coming together and all of a sudden they're annihilating, that could create some heat. Because these things are ginormous. It's like, you got like the sun to the earth. It's like, I don't know, like 93 million miles or something like that. And it's like, all right, take that times 10. Yeah, we're going to Kaoken times 10 there. Or, yes, astronomical units times 10, rather. Yeah. And they glow brighter than some galaxies, apparently. That's what's being conjectured there. However, their temperature is quite low, only like around 10,000 degrees, where population 3 stars, which coincidentally we call population 3 because we haven't seen them yet, have been conjectured to be the mostly lacking metallicity stars. What do scientists mean by, or at least folks within greater cosmology and astronomy? And I kind of get those confused sometimes. I'm still not exactly... one is cosmogenesis, the other is actually just the observations, I believe. I'm sorry, my friends there. But essentially, what they're saying is if you had a really big population of 3, it would probably be a lot hotter because it's actually being powered by fusion rather than... Basically, that annihilation allows it, as far as I understand, the density not to increase where it starts fusion there, but grow ginormous. So let's just jump into it. So basically, we went through some of these dots before. These were supposed to be extremely high redshifted galaxies. That means they're working far away. And we're like, wait a second, should these things even be here? So since some folks had proposed that this was an option, that seems to fit some of the observational data, why not do a paper on it? And we get to say things like bright dark stars may just be galaxies. We don't know. More data apparently will help us figure this out. This is brought to us by our friends at Reuters. Washington, D.C., July 17th, Reuters. Scientists for the past 15 years have been looking for evidence of a type of star only hypothesized but never observed, one powered by the fusion of atoms like the sun and other ordinary stars by mysterious stuff called dark matter. Oh my god, the chaos that's blowing in the videos! Oh, I closed the other article where I had taken, I give a citation, but just the ads on the internet, I'm just like, well, these are reputable websites, just based upon my observations, at least what I've heard. All right, thanks to the James Webb Space Telescope's ability to peer back into the dawn of the universe, the first good candidates to be dark stars have been identified. All right, 3 objects spotted by Webb, which was launched in 2021 and began collecting data last year, were initially identified last December as some of the universe's earliest known galaxies. But according to researchers, instead might actually be humongous dark stars. Dark matter, invisible material whose presence is mainly on its gravitational effect at a galactic scale, would be small, but crucial ingredient in dark stars. These stars are described as made of almost entirely of hydrogen and helium, the two elements present during the universe's infancy, with about 0.1% of their mass in the form of dark matter. But self-annihilating dark matter would be their engine. Yeah. Okay, basically, just to sum it up here. Dark matter is visible to us, but does not produce or interact directly with light, but it's not to account for about 85% of the universe's matter, with the remaining 15% comprising normal matter like stars, planets, gas, dust, and earthly stuff like pizza and people. Dark stars would be able to achieve a mass of at least 1 million times greater than that of the sun, a luminosity at least 1 billion times greater, with a diameter roughly 10 times the distance between Earth and the sun. Right on there. Hey, Fractal. Hey, thank you for joining, my friend. Yes, fascinating stuff. We covered that the other day. I should reach out to Professor, I believe, Gupta. I think I'm going to shell out the $25 and actually review the article at some point. Dude, a subscription to that Royal Society Journal is like 12 grand for a year for only online access. Jeez. This Professor Keating was straight up. He's like, this is paywalled. Well, he helped bring us some of the stuff. Okay. We go to the article. This was published in, the Proceedings of the National Academy of Sciences. That's a journal. This isn't paywalled. It's only a couple pages long. All right. In 2007, we proposed the idea of dark stars, the first phase of stellar evolution in the history of the universe. Maybe dark stars, DS, powered by dark matter, DM, heating rather than by nuclear fusion. Although made almost entirely of hydrogen and helium from the Big Bang, they form at the center of proto-galaxies, where there's sufficient abundance of dark matter to serve as their heat source. They are very bright, diffuse, puffy objects, and grow to be very massive. In fact, they can grow up to 10 million solar masses with up to 10 billion solar luminosities. In this paper, we show that the James Webb Space Telescope may have already discovered these objects. That's pretty neat. My one thing is, I'm hearing 0.1%. I'm pretty sure I heard Professor Carroll in one of his AMAs the other day saying, oh, there's dark matter everywhere. It's like, all right, that's cool. It's like, if it kind of seems to be forming a cloud and is present seemingly through all the stuff and things we basically seem to observe. It seems to be, I don't know, almost like a chaos, like an aura, if you would. And again, this is conjecture and speculation based upon things I've seen on the internet. When there be more dark matter? Like, isn't that less than normal? I don't know. Maybe things are different. Maybe it just happens to be in that very and again, they're saying it's a particular type of dark matter. So that might be a lot of dark matter to go around. At least that's what the speculation is. Basically, if it's an all antiparticle, so you're emitting heat. So there's still enough motion within this cloud and everything where it's just a speculation. Sure, basically they go into this appears to be because of the Lyman break. They're like, oh, there seems to be a lot of hydrogen and stuff there. If they get a good measure in the spectroscopy, basically kind of like the light fluctuations depending on how light is going through different molecules and everything. We apparently know a lot of that. Maybe it is dark stars. Maybe they're just really old galaxies. I guess we're going to have to find out. Yes. Hey, well, that would be interesting. Hey, any type of matter, apparently, as long as you have mass, rumor has it, you can create energy. First generation of stars in the universe is yet to be. The first generation of stars in the universe is yet to be observed. There are two leading theories for those objects that mark the beginning of the cosmic dawn. Hydrogen burning population of 3 stars and dark stars, made of hydrogen and helium, but powered by dark matter heating. Latter can grow to become supermassive. Oh my God. It's like 10 million solar masses. Or excuse me, 1 million solar masses. Extremely bright. Yeah, 1 billion solar luminosities. That's what the article said. So they have the JADES objects there, basically at their redshifts, apparently. Oh, I think they've adjusted some of these. are consistent with supermassive dark star interpretation. Okay. So they appear to see objects that could potentially fit it. So they go in through here and they're fitting it, and they actually do some math here. I haven't gone through all. So basically, yeah, it looks like they're only surface temperature is about 10,000 degrees. This is the big thing, because if it was just a star or something, maybe it's a galaxy, maybe there's a quasar or something there. Maybe that's kind of weird for some of our models, but still seems to fit within the lambda CDM paradigm. Again, you're going to propose something that's a little bit different we haven't seen. Again, I think there's like a 2.5 signal, like 95% or so. Apparently you want at least 3, 5 would be great. If you'd have 1 in a million chance of it just being some interference, and especially what are you actually observing there? Going to the dark stars. This is the molecular clouds of hydrogen collapse inside. Oh my god, I should have been big in this. I apologize, everybody. There we go. So molecular clouds of hydrogen collapse into early mini halos in the process of star formation. Large reservoirs of dark matter at the centers of these mini halos can play an important role. If dark matter particles are their own antiparticles, if the dark matter particles are their own antiparticles, that's important here, then their annihilation provides a heat source that stops the collapse of clouds, in fact, produces a different type of star, the dark star. In thermal and hydrostatic equilibrium, we should emphasize that dark stars are made almost entirely of ordinary matter, hydrogen and helium, but powered by dark matter. Even though the dark matter only constitutes less than 0.1% of the dark star, we consider 2 types of dark matter particles: weakly interacting massive particle dark matter particles, so WIMPs, and self-interacting dark matter particles. Okay, so you get the 2 particular. So the normal dark matter basically doesn't really interact with much anything. And then self-interacting. So perhaps this could be a guide for a new particle, or just be something else. It's kind of a cool thing. All right. So they go into the equations there. Okay, so it looks like they're doing density. There are assumptions being made, but you know what? They actually published something. It's more than I've done in a long time. Well, YouTube, but hey, I actually went through a bunch of that. All right, they proposed it. Go through, where are the... Okay. So basically, and again, I believe some of these estimates for distances have been revised by some of the scientists for the JWST, because you're like, oh my God, this appears to be different there. But then again, there's a lot of interesting stuff and things, and rumor has a lot of folks there. They got questions. What might be going on? All right, so we got these figures here. And again, could these potentially be galaxies? Basically, the increased spectroscopy, the observations of the different light and its wavelengths should help yield some data on that. Could be galaxies, but basically they say that at one point there. Actually, let's go back. It'll take too long to search. Okay. So basically, yeah, we get the thanks to Wikipedia. I think a lot of this was probably updated more recently, but I look back, I'm like, all right, they had a paper. What was the actual paper? I think it was like cited 2010. Dark matter powered the first stars. Okay, so again, from 2007, so they're citing the research. It was a prediction. If you see evidence that seems to fit the prediction, you go with it. See if it pans out. But basically, the neutralino and supersymmetry. The neutralino is a hypothetical particle in a minimal supersymmetric standard model, MSSM, a popular model of the realization of supersymmetry at low energy. Therefore, neutralinos are fermions and electrically neutral. The light switch at stable R parity, yada yada. Oh my God, this is so funny here. It's like these 4 states are composites of the Beano and the neutral Wino, which are the neutral electroweak gauginos and the neutral Higgsinos. And the neutralinos are majora fermions, each of them identical to its antiparticle. Every once in a while, I sit back and I'm like, I think physicists may be some of the best trolls. It's a beautiful thing. All right. But basically, what they're saying here, neutrino dark matter could be observed experimentally in nature, either directly or indirectly or directly. For indirect observations, gamma rays and neutrino telescopes look for evidence of neutrino annihilation in regions of high dark matter density, such as the galactic or solar centers. For direct observation, special purpose experiments such as the cryogenic dark matter search seeks to detect rare impacts of WIMPs in terrestrial detectors. Apparently, there was a scan like about a year or so ago, and people were like, yeah, we have an extremely high confidence. We've basically seen dark matter everywhere, but I don't think they've released their findings, or at least the data to really anybody yet, which is just interesting. Just have some questions. So I got as well. I would say universe has a sense of humor. I wouldn't disagree with that either. But that's some interesting stuff there. But yeah, that's all I got for right now. It's an interesting thing, but we got a whole heck of a lot of new data with the Gaia telescope and everything. That combined with machine learning, I think we're going to start to figure a lot of stuff out really fast. And I think it's going to be exciting as heck and one hell of a ride. At least that's what I'm going to claim. But that's all I got for right now. Peace out, everybody. Take care of yourselves. It's a wacky and wild world out there, but I think the best is yet to come. Catch you all